Here we look at each process type individually, their role, when we deploy more than one instance of a given process type, and network configuration. WPs in particular have different subtypes and roles which we need to consider. At the end, you'll be in a position to describe each type, subtype, and role. So let's start with the full list of AE processes. They can be broken down into two major groups: communication processes, which guarantee communications between components, and work processes, which support workload management and other tasks. We start with standard WPs with a W type. A standard WP carries out generic workload responsibilities like the execution of tasks and status reporting. We have the primary work process with the P type. In short, when the system is initiated, the first WP is automatically designated as the primary. The PWP manages a number of core responsibilities like synchronizing regular WPs and handling specific time-based tasks. While we can have multiple generic WPs, there is only one PWP. The CP type C manages communications between components. For example, workload instructions issued by the WP are carried to the agents via the CP. The CP also handles AWI connections. The CP is passive. It waits for connections from components, including other processes, and forwards the information. The JWP and JCP, types J and A respectively, are both the Java-based counterparts to the conventional CPs and WPs. The JCP in particular handles Java-based features like AWI and the REST API. Finally, there's a special type of WP called the Dialog work process, which assumes responsibility for certain interactions between users, AE, and AWI messaging. We start with the CP, which listens for incoming connections from other components, like a WP and a task submission, an AWI connection via logon, an agent connecting to AE, the Java API, and more. The CP simply ensures communications across the entire landscape. Automic recommends starting multiple CPs for the purposes of load management. Obviously, communication processes must be available over the network. For this, ports are defined in ucsrv.ini, and the default range is set between 2217 and 2221. The WP is the core workload process. It handles basic tasks in the automation engine, including calculating and executing, status reporting, and messaging. It's in constant communication with the CP to support workload operations. When the system starts, the first WP in the start sequence automatically assumes the primary work process, or PWP, with type P and is assigned to ports, which by default is set to 2270 in ucsrv.ini. All subsequently started WPs assume workload responsibilities. Standard WPs themselves are not assigned ports, since their activities are synchronized by the PWP and the CPs. When a PWP stops, another WP automatically takes its place. Finally, when the system is shut down, the PWP should be stopped last. The Dialog work process, type D, is a WP that does not assume conventional task execution and status management responsibilities. Instead, it handles certain transactions between users, the automation engine, and messaging in the web interface. It does not have an assigned port. Its activities are coordinated by the PWP. Dialog processes are optional, and in very small instances you can do without them. But we do recommend deploying them because they lead to substantial improvements by alleviating much of the work that the PWP has to do. You can set the number of WPs versus DWPs using a setting called WP_min_number in the UC system settings variable. You set the number, and this guarantees a base number of WPs that cannot be converted to DWPs. Note that no WP with a server role, something we explore in another video on processes, can be converted to a DWP. To perform the conversion, we have a function called server mode in the context menu. This allows us to switch a WP to either PWP or a DWP. When we do so, processes are reconfigured automatically. The Java work process, type J, handles workload responsibilities for features that are Java-based. By default, the JWP is networked and assigned a port based on availability. It is possible to have several of these for the purposes of load management. Here we've listed some of the features that are supported by JWP, like service level management tools, the process monitoring perspective, object searches, and export with references. Likewise, there's a Java communication process, type A, which again supports Java-based features. In particular, it serves as the endpoint for the REST API and is assigned a random available port by default. The REST API endpoint itself is assigned the 8088 ports. We have provided information on how to start these processes on the command line on Unix. Note the -i option to invoke the ini file and the executable names. The same jar file is invoked for both the JWP and JCP, although the latter requires the -rest option at the end. These are the commands that are executed by the Service Manager, which is by far the cleanest and most effective way of starting and stopping the system. On the CLI, they can be stopped with kill commands. The REST API endpoint itself is assigned the 8088 ports.